Welcome to Model 4.2, our second case study on urban sanitation. This time we move to China and explore an urban ecosan pilot project implemented between 2004 and 2009 in Inner Mongolia in China. We chose this case study because it is one of the best documented cases of a failed attempt to introduce innovative ecological sanitation solutions to a new housing estate. We'd like to thank the Stockholm Environmental Institute, and especially Jennifer McConville for providing us with the information shown here. Erdos was a Chinese-Swedish ecotown project that aimed to test new frontiers of waste management. It involved 832 apartments and housed around 3,000 people. When the project was initiated in 2003, Erdos was just beginning its rapid expansion, and much of the existing sanitation provision was still very poor. Only 1/3 of urban households in Erdos used modern flush toilets, and the city periphery was not connected to any sewers and mostly relied on on-site solutions. This slide shows the location of the Erdos project area in Inner Mongolia and northern China. It is one of the fast-growing areas of inland China thanks to exploration of gas and oil fields. Some of the features of Dongsheng district: the population was about 250,000 back in 2003. The area is between 1,400 and 1,600 meters high, with a wide range of temperatures from -30 degrees in winter to +30 degrees in summer. However, by 2007, already 75% of the urban area was sewered, in line with many Chinese cities. It should be noted that Erdos lies in a water-stressed region with low rainwater fall, and that historically, the use of waste as a fertilizer was quite common. The project developers decided that this was an enabling base for testing newly proclaimed Chinese recycling economy. This slide shows the project rationale. On the right side, you can see a promotional flyer that was shown and distributed to attract buyers for the residential property in Erdos. The modern apartments tried to sell the eco features: energy saving, innovation in sanitation systems, and water savings. It thus formed a keystone of the recycling economy that became the national policy of China. The housing estate was developed by a private-public partnership with a private developer, the Daxing Estate Company, as the main investor. This slide shows the project timeline. The project was initiated in 2003 by the Dongsheng district government and the Stockholm Environmental Institute. In 2004 and 2005, the housing estate was constructed, one of the buildings shown in the middle on the bottom. In 2006, 832 apartments were completed and the households started moving in. The photo on the right shows the source separating toilet, dry toilet used for all apartment buildings. In 2008, 2 of the buildings were retrofitted with improved dry toilets. And in 2009, due to high dissatisfaction with the sanitation system, all households decided to change the entire sanitation system and to revert back to conventional flush toilet systems. In 2011, SEI conducted a project evaluation and published a book about its findings in 2012. Some of the design considerations of the Erdos project: it featured a sustainable environmental sanitation system with a closed-loop separated waste streams. This included separation of feces, urine, grey water, and solid waste, and the recycling use of human waste for fertilizer. This slide shows an overview of the sanitation system. Firstly, feces and urine being separated in the dry toilet, shown here in the user interface. The feces and sawdust were collected in a cellar in plastic bins, collected and transported and brought to a thermal composting plant, and finally, after treatment, brought to a demonstration garden. The urine was collected in an underground urine tank, pumped out at regular intervals, and also brought to the demonstration garden. This slide shows the system design in a section of one of the apartment buildings. It shows the different urine diverting dry toilets, shown here in green, which are connected to dry collection systems or chutes, which were used as pipes with 280 millimeter dimensions. Additionally, there were vent pipes connected to each toilet that ventilated the toilet systems. These pipes were 110 millimeters thick. And finally, the bottom of the system in the cellar, the feces bins that were connected to each of the toilets. The system as it is shown here is the first attempt at introducing urine diverting dry toilets in multi-story apartment buildings. Let's look at the system design. The picture on the left shows the dry chute that are connected to the collection bins in blue. Additionally, there were 22 underground urine tanks that collected the urine from the different toilets. And there were also ventilation systems connected to each toilet that led to the roof. The image on the bottom left shows the on-site treatment station, thermal composting of feces that could treat 1.5 tons of feces per day. Additionally, there was a grey water treatment system that consisted of anaerobic tanks and sedimentation tanks that could treat up to 250 cube meters per day. The compost and urine could both be used in the adjacent demonstration garden next to the housing estate. This slide shows the user interface, the heartpiece of the eco-sanitation system. It featured an innovative dry separating toilet with the Teflon-coated turning bowl that separated the users from the waste. It also featured sawdust instead of water. The sawdust was added to minimize the odor problems, but also to speed up the drying process of the feces. The separated urine was collected in an underground tank, shown here in this section, and was initially used in agriculture. Later on in the project, it was also dumped at municipal landfill sites or even at clandestine locations by the emptying company. The project also included user sensitization. This was conducted through initial training events after the households moved in. They also distributed flyers and reminders about the correct use of the facilities and introduced a telephone hotline where people could complain about malfunction of their system. The Stockholm Environmental Institute also conducted regular user satisfaction surveys, and this user survey from 2007 and 2008 shows two of the main problems that arose quite early in the project. In blue, the odor problem, which was most pronounced during the cold months, especially in December and January, and the toilet mechanism, especially the turning bowl parts and the ventilation, which are featured in red. In the next model, we'll be looking at some of the reasons for the system failure of the Erdos project and why the dissatisfaction with the toilets and the sanitation system eventually led to the dismantling of the existing system and replacement with conventional sanitation flush toilets.